Welcome back, Surf Coaches community. Brent back again, and if you haven't already checked out the last video we put up about swell forecasting, definitely check that out. But this is a little more in depth about what all the numbers mean when you go to look at a swell forecast. So what the things I want to talk about today, the three main numbers you're always going to see every time you check a swell forecast are the swell height, the swell period, and the swell direction. So before we get started, I want to let you know where all these numbers come from. Basically, they come from usually from buoy readings and also from people taking storm models and putting them into the computer and generating these numbers. And I'm going to talk to you about what each one of them means and how they relate to surf in your local area. So the first number you're going to see at every swell forecast is the swell height, and it's usually either in feet or meters. So I have the swell height here, and I have a graph here. So the height, what that refers to is that's the height measured at a buoy offshore from the base of the wave to the top of the wave. So usually, again, in feet or meters, a common reading would be like 2.8 feet, 4.6 feet, and that's the average swell height for waves passing over a buoy. The next number you'll see will be the swell period. So you'll see the height, 4.2 feet, for example, at a certain amount of seconds. And that's the swell period or the frequency. Now, the way they get the frequency is they measure the time lapse between trough to trough or peak to peak. So that's the average amount of time that passes from when a peak of a wave passes a buoy till the next peak. And the last number you'll see is the swell direction. It's always measured in degrees. So you might see a surf forecast that says the swell height's going to be 4 feet at a 16-second period out of 180 degrees. And the degrees refers to which direction it is coming from. So I've got a compass kind of thing driven here with north, south, east, west. And just a note, 0 degrees is due north, 90 degrees is due west, 180 degrees is due south, and 270 degrees is due west. So the first part of this equation I want to talk about is the swell height. Now, this is most common you'll see, and this is what a lot of people look at. And the swell height refers to the height of the waves coming in, or the swell coming in out in the open ocean, as measured by buoys or ship readings. Now, the height is usually measured in feet, although sometimes it can be measured in meters. And the height is from the base of the wave to the peak of the wave as it passes by the buoy. Now, one thing I want to note is that does not always mean the height of the wave. So you can see a swell reading that says the waves are 10 feet at whatever seconds. And sometimes people say, oh, the waves are going to be 10 feet tomorrow. That is not always true. At the same time, the waves can say that it's going to be 2 feet at a longer period. And that doesn't always mean that the waves are going to be 2 feet, because it's really dependent on the period, which we're going to talk about next. So the next part I want to talk about is the swell period. And in my mind, the swell period is one of the most important things about reading a swell forecast. So just for starters, when you look at the swell period is measured by the buoys offshore, and that measures the distance in seconds from trough to trough, so the low points of each wave, or from peak to peak. It really makes no difference, and it basically takes an average over time. So the period is probably one of the most important parts of the swell, because the period directly correlates to how much energy is in the swell. So the longer the period, the more power and the bigger wave. So a swell, for example, that has 2 feet at 8 seconds and a swell that has 2 feet at 16 seconds is going to have way more than double the power in each wave. One other note I want to make about the period that's a common misconception people ask all the time. I say, okay, tomorrow the waves are going to be only 2 feet at 14 seconds. And they say, well, I went out surfing, but the waves weren't 14 seconds apart. Well, that's not exactly what that means. Again, these are readings that come from buoys that are offshore, and it measures the mean distance, the average distance between peak to peak, trough to trough. And as the wave approaches the beach, it actually kind of changes, and I'm going to show you guys that in the next segment. So now what I want to talk about is swell period and why the period of the swell is so important to forecasting waves. So what I have here is a short period swell and a long period swell coming along the same beach, a nice sloping beach break, and the waves are both coming in this direction. So we'll start with the short period swell. So these swells are the same height, 3 feet. This one's 3 feet at 8 seconds. So that means that the height of the swell at its peak out in the open ocean is 3 feet, and the distance between waves as the swell train moves in is 8 seconds between peak to peak. So as this wave moves in, what happens is this front part of the wave starts hitting the beach kind of early. It starts slowing down. It encounters friction. So as this front part of the wave hits the beach, it starts slowing down. But the back part of the wave back here 8 seconds later, it's still moving much faster because it hasn't encountered the same friction. So what it does is it builds up as it moves here, so it causes the wave to build up into a breaking wave. And on average, a wave that's 3 feet at 8 seconds will turn into about a 2 to 3 foot wave on your average beach break. So now when we look at a long period swell, the same swell height out in the open ocean, 3 feet, okay, from base to the peak, but now the swell period is 16 seconds, so it's double the distance. So why is that important? Well, as this wave moves towards the shore, the front part of the wave starts slowing down, just like this one, and then the back part of the wave is 16 seconds behind it, and it's so much longer of a wave that the wave builds up more and more. So it's almost like a train wreck or a car wreck on an interstate. The first car wrecks, and if you only have 5 cars and they pile up, versus if you have 15 cars and they pile up, it's going to be a bigger buildup. So basically what's happening is this is building up even more because this part is moving so much faster. And a good analogy you can think of is if you were riding down a hill on a bicycle. So you're riding down a very mellow hill and you're going down the hill and you run into a brick wall. If you're going really slow, you're only going to get tossed out a little bit, whereas if you're going down a steep hill and you're moving much faster, which long period swells move faster, you're coming down, you're going to hit the brick wall, stop just like the front of the wave stops, and the back's going to fly up even more. So the last thing I want to talk about today is swell direction and explain why swell direction is important. So what I did is I drew a diagram of my home state of Florida, and I'm going to explain how swell directions affect waves that come in here. So I drew a couple places. You have North Florida, Central Florida, South Florida, and if you look at the state here, we also have the Bahamas offshore, and I'm going to explain why swell direction is important, because if you have the wrong direction, it means you can be completely blocked from swell, or the swell can't make it into a certain area. So what you'll see is when you look at a swell, it'll say maybe 3 feet at 16 seconds, and it'll give you the degrees. So the degrees will be, say, 90 degrees. So you can look at this and know that 90 degree swell, a swell out of 90 degrees, means a swell coming straight from the east. If the swell is coming straight from the west, it'd be 270, coming straight north, 0 degrees, south, 180. So why is that important? Well, over the years, I've had friends come to me and say, Brent, the waves are going to be so good tomorrow. It says it's going to be 10 feet at 12 seconds, and the waves are going to be great. And I go to look at a swell forecast, and they're right. It's 10 feet at 12 seconds, but the degrees is 270, which means the swell is out of the west. So if I'm here, and the swell is coming from this direction, guess what? There's no real swell. That means the wind and the swell is all blowing out to sea, which means no waves at your local break. So if that same swell were to turn around and be out of 90 degrees out of the east, that means swell is going to be coming straight at the place at any of these directions. Another reason swell is important or swell direction is important is because we often have islands offshore that can shadow or block swell. So we'll look at this diagram again. We have 3 different places in Florida. So say the swell is coming out of 90 degrees out of the due east, coming straight at Florida. Well, guess what? If you're here in Central Florida or North Florida, the swell is going to be able to come in without getting blocked at all. Whereas if you're here in South Florida, guess what? The swell's coming in, and then it gets blocked by the islands offshore. Now, this is very common in places in England, in Southern California, and of course here in Florida. So knowing the swell direction is very important. Also, at the same note, there's often times where the swells will come down the coast. So if you have a swell that's coming straight north, for example, in this here, the swell's coming straight out of the north. Guess what? It's going to go right by North Florida. It's going to go right by Central Florida, but it can come all the way down and actually hit places in South Florida. So what's really important is do a little research about the area that you're surfing in, and know you can go look up. Surfline's a great tool. You can look up in the archives. So if you remember that 2 months ago on Tuesday, the 27th of May, the waves were amazing. You can go look at the archives and see what the swell was doing. So that way in the future, when you go look and you're checking swell forecasts and swell models, and you see those same numbers pop up, you can say, oh, I remember last time it was like this, the waves were amazing, or I remember last time that I freaked out and I drove to the beach and there was no waves at all. You can kind of make those correlations, because at the end, swell forecasting is just like weather forecasting. We're making our best guess based on commuter models off storms, but we're trying to predict the weather and the waves, which is not easy to do. But if you have a little bit of insight and know what you're looking for when you look at these models, look at these graphs, look at these numbers and charts, it'll give you an edge on where to find the best waves and have the best surf all the time. So guys, I hope you enjoyed the tutorial. Of course, as always, if you have any questions, please put them in the comments below. I'm more than happy to answer any and all of them for you guys. If you haven't already subscribed, please subscribe to the channel. Give us a thumbs up. Also, don't forget, check out our podcast live on iTunes. It's becoming very, very popular. You can take us with you anywhere you go. And guys, until the next video, I'll see you.